So in this question it says, consider the following facts. Water freezes spontaneously at -5 degrees Celsius and 1 atmosphere. And ice has a more ordered structure than liquid water. Explain how a spontaneous process can lead to a decrease in entropy. Alright, so we're talking about basically the signs of delta H and delta S here. So on the sides we have delta H, here it's positive and here it's negative. Here we have delta S on the top, positive and negative. Now here, it'd be spontaneous at high temperatures. Here would always be non-spontaneous at all temperatures. Here it'd be spontaneous at all temperatures. And here it'd be spontaneous only at low temperatures. Now we are freezing water. Freezing water means we're going from solid to liquid. So this is a phase change. During a phase change, both delta H and delta S agree in sign. Now, we're saying here, freezing means you're going from solid to liquid. We release energy so that molecules slow down so that they can stick together. So it's a negative delta H. It's exothermic. At the same time, entropy is decreasing, so it's negative delta S, which means we fall here within this Punnett square. This equation is connected to delta G equals delta H minus T delta S. All right, so this here is negative, okay? And here, it's spontaneous at low temperatures, meaning that if we make this number small enough, because remember what's happening here is this is a positive temperature multiplying with a negative delta S now. If you make the temperature a small enough number, that means that the overall answer here will be a smaller negative value. So a very small negative value is important here because a negative times a negative gives me a positive. Okay, and here you can still have a negative delta G overall as long as your delta H is negative enough. That's how we're able to have a negative entropy and yet still be spontaneous under these situations. Because here, under these conditions, make the temperature low enough, you can get your reaction to become spontaneous because it works out mathematically within this formula. That's how you would approach this question, and that's how you'd set it up to explain how you can still have a negative delta G even though your delta S is negative as well.